Welcome everybody to Algebra 1, Section 5.5, Slope from a Graph and Slope Formula. So we're first going to talk about rate of change, and rate of change is going to be defined as a ratio that shows how one variable changes with respect to another. On a linear graph, this is more specifically called slope, or the slope of the line. Now, slope is written as a ratio, hence rate of change being a ratio and the rate of change being the slope on a graph. It can also be thought of as the vertical change, aka the rise, to the horizontal change, a ratio of the vertical change of the rise to the horizontal change of the run, so a comparison of those two between any 2 points on a line. So for example, we see 3 different points, and you could compare any 2 points and say how much does it go up, rise, versus going over, running, and rise versus run as well. Or we could even go from the first to the third. This remains constant for any 2 points on the same line. So the slope from this first line to the second line would be the same as the second to the third line, or second to the third point, I should say. And slope is written as a fraction in simplest form. And our variable used for slope is m. So there are 4 types of slope because there are 4 types of things, or 4 things that fractions can be. And since slope's written as a fraction, that is the case. So the first thing a fraction can be is positive. And if the slope is positive, it'll look like this, which looks like it's going uphill from left to right. So L arrow right, aka left to right. So from left to right, it looks like it's going uphill. The second thing slope could be is negative. The fraction could be negative. And if the slope is negative, instead of looking like it's going uphill from left to right, it's going to look like it's going downhill from left to right. The third thing that slope could be is 0, because a fraction could be 0. And this would look like a perfectly horizontal line. So this line is horizontal. And you could think of it as the rise equals 0. So since slope is a fraction, and more specifically we're going to think of it as, it'll be down here, but I'm going to go and write it now as rise over run at the bottom left of the screen. See how much it goes up and down compared to how much it goes left and right. It is running 0, or excuse me, it is rising 0. It's not going up or down at all between any points, but it is running any number you could think of. And 0 divided by any number other than itself is 0. Now, another little trick you can know to remember this is that you can make a z out of this line, and that z would stand for 0. And then our third thing our fourth and final thing that a fraction and slope could be is undefined. We get undefined fractions when we are taking any number and dividing by 0. As far as the line, this would look like a vertical line. And here the run would equal 0 because it's not moving left to right at all. So the rise is some number, the run is 0, and any number divided by 0 is 0. And here, instead of making a z for 0, we can make a u for undefined. It means, once again, that's the first letter of the word undefined. So now let's practice finding the slope on these graphs. So on number 1 through number 16, quite a lot of these, we're going to find the slope by counting the rise over the run, the rise and the run, and making them a fraction and writing our answer in simplest form, so reducing the fraction as needed. So on number 1 here, from this point to this point, the graph isn't the easiest to see, unfortunately, but hopefully you can at least see the intersections for where new values start for x values and y values for the integers, such as 1, 2, 3, and so on and so forth. And so from this point to the next point, it goes up 1, 2, 3, 4, 5, 6, 7. So meaning the rise is 7. So as we do our slope, we'll put 7 on top of the fraction. And as we do our run, we're going to go over 1, 2, 3, 4 for the run. And so it's a rise of 7 over a run of 4. And so the slope is 7 over 4. And now notice that since we rose 7 up, that went positive 7. And we ran 4 to the right, that's positive 4, because movement up and movement right are both positive, creating a positive fraction. We could also know our slope is positive because we went uphill from left to right, and we said that was a positive slope. Now, you might be wondering, Mr. Kossel, what if I went the other direction? It wouldn't be positive anymore. And I'd say you're right, it wouldn't be positive anymore for either number. So we go down, and we go down 7, and it ends up being negative 7. And we go left 4, and it's negative 4. And even though neither number is negative, a negative divided by negative is a positive, and you get the exact same answer of 7 over 4 after we simplify anyway. So it doesn't matter which point you start at, regardless, you get the same exact answer. So on number 2, and as we go through these, I'd encourage you to pause the video, work on these ahead, and then continue the video and see how you did. On number 2 here, we went down 3, so the run is the rise is negative 3, and then as we go over from here to here, that ends up being 9 across, and so that's negative 3 over 9, which does reduce to negative 1/3 for the answer. If you went the other way, you would have gotten a positive 3, a negative 9, which once again still creates a negative 1/3. Now remember, where the negative is on a fraction doesn't even matter a little bit. So the negative could be on the bottom, or the negative could be out in front. And regardless, the fraction as a whole is negative, and that's what matters. Number 3 here. So between these 2 points, we note that we rise 0. We don't rise at all, but we do run 4. And 0 divided by any other number is 0. And you also could have known this was 0 because it's a horizontal line, and all horizontal lines have a slope of 0. The little z trick can help us remember that. On number 4, if we find the rise over the run, the rise from either point, one way or the other, is either going up or down. In this case, let's say we go down, just for grins and giggles, we get negative 5. Or if you went up, you would have called it positive 5. Either way, it won't matter. The run is 0 from left and right. We're not moving left and right at all. And any number divided by 0 is undefined, which we can shorten to UND if you would like. If you're wondering how you spell undefined, it's written right above for the fourth of the 4 types of slope. Let's move on to the next page here as we go to number 5. Oh, sorry, I should also mention that you can do that little trick there for this where you can make a U for the undefined line, or the undefined slope, of the vertical line. So number 5, as we go from one point to the other, the points are here and here. They might be a little bit hard to see. We note that the rise is 5 over 3. Can't be reduced, so we're done. On 6, the slope is negative 3 over 1. Negative 3 over 1, you could leave your answer like this, or you could simplify it to negative 3. They're really one and the same because the numbers didn't get smaller. It's just choosing whether to write the divided by negative 1 or not. And either one would be perfectly fine there. Number 7, as we find the slope here, the rise is 4, the run is 2, which reduces to 2 or 2 over 1. On number 8, the rise and run is negative 4 over negative 4, or positive 4. Let me try that again. Negative 4 over positive 4, if you started at this point. Or if you start at the other point, it's positive 4 over negative 4. Regardless, this reduces to a negative 1. On number 9 here, the rise and run, the rise, if I start, I always go from the left point to the right point personally, so that's going to be how you're going to see me do these as well. I should mention that from 9 through 16 on, as well as how I've done them so far. But if you go from the right to the left, you just have the opposite signs for what I have as far as which number is positive, which number is negative, and all of that stuff. So here I end up getting negative 3 over 4, so the opposite of that would have been positive 3 over negative 4, which once again, as long as the fraction is negative, it's the same thing. The next one would be negative 5 over 1, which you could just call negative 5 if you'd rather. Making sure I do at least include the negative though, or negative 5 over 1 would have been fine. Number 11 is a vertical line, which once again we can make the u out of. So the slope is some number over 0. We don't really care what number you choose to pick, but regardless, it ends up being undefined, which you don't even necessarily have to do this part if you don't want to, but you're fine doing it too if you'd like. Number 12, the rise is 2, the run is 3, so 2/3. 13, we end up getting a rise of 1, a run of 4, so it's 1 over 4. On 14, the rise is negative 2, the run is 4, and we end up getting this to end up being negative 1/2. I do want to quickly remind everybody that we notice any slope that's going downhill from left to right will end up being a negative number. So we see that on 14, we saw it on 10, we saw it on 9, we saw it on 8, and we saw it on 6, for example. Whereas any slope that goes uphill from left to right will have a positive slope, which once again we see, it's not once again, but we see that on all the other ones I didn't mention other than number 11, which would be 5, 7, 12, and 13. Moving on to our last two on this page, number 15, the rise over run is 2 over 6 between those points, which is just 1/3 when we simplify that. And then number 16, this is a horizontal line with the slope of 0, or 0 divided by any other number, or 0 divided by any other number, I said that correctly, would be 0. Let's move on to the next part. We're going to use slope from points. So we use slope from a graph, and now we're going to identify slope with points. And so we're going to do this using a formula. The slope formula is used to find the slope between any 2 points, and points are written as x, y. And so specifically, if we have 2 ordered pairs, an x and a y and another x and a y, we need to differentiate which ordered pair is which. And so we call one x1, y1 for the first ordered pair, and the other one we call x2, y2 for the second ordered pair. And actually, it really doesn't truly matter which ordered pair you call the first and which ordered pair you call the second. I'll dive into that as we begin working on these in a moment. But first, the formula for slope is m equals y2 minus y1 over x2 minus x1. And to clarify, the y2 and y1 and x2 and x1, the 2 and the 1s, are not multiplying with y and x. They're not exponents on them. It's just merely describing which y and x we're talking about. Let's say that we're talking about the second y or the first y or something like that. Now, as we work through these, remember that it is important to simplify your answer. That's why it's in all caps with an exclamation at the end and in bold with asterisks on the side. So very, very important here. And so we're supposed to find the slope between the pairs of points. So as we do this, we need to pick one of the points to be x1, y1, one of the points to be x2, y2. And once again, it doesn't matter in the least, okay? So you personally might say, oh, this is x1 and y1 just because it comes first. Cool, good for you. And this one would be x2, y2 because it comes second. Cool, sounds good to me too. I personally always like to make the one with the bigger y value my y2, which we'll see why in just a moment. Now, as we set up our formula, this is kind of the bare bone structure we have, or the skeleton structure we have that we just fill things in. And so we're going to have something minus something on the top and something minus something on the bottom. And so on the top, it's y2 minus y1, or in this case, it'd be 3 minus 1. And on the bottom, we're going to have x2 minus x1, which would be 4 minus 1. Now, the top here ends up becoming 2 as we simplify, and the bottom becomes 3, and the slope is 2 over 3. Now, you might be wondering, Mr. Constable, what if I had switched these around and I called this one x2, y2, and the other one x1, y1? What would happen here? Well, that's a great question. Thank you for asking that. And so what we would do is we'd still have our little structure here as far as how we complete this and how we fill things in. And now, instead of 3 minus 1, it's 1 minus 3 on the top. And on the bottom, instead of 4 minus 1, it's 1 minus 4. And this ends up becoming, oh, I should not use red there. The red and the orange go too close together. I'm going to change that to blue. So 1 minus 3 and 1 minus 4. And on the top, as I work my way through this, I end up getting m to equal negative 2 over negative 3. And a negative divided by a negative, last I checked, is positive 2 over 3. So we get the exact same answer. Our signs on both the numerator and denominator just happen to be the exact opposites of what they were before. And you'll notice that being the case every time. If you do it one way and your partner or a person next to you does it another way, where you call one order pair 1 and one order pair 2, aka x1, y1 and x2, y2, you're just going to get opposite signs from each other on the fraction. But then by the time you're done with the problem, the answers will be the same if you did all your math correctly. Now, what you cannot do, what I emphasize here, is that you cannot say put 3 first on the top and put 1 first on the bottom. So, but which order pair came first, whether I put 3 first on the top or 1 first on the top, didn't matter. But what I can't do is, once again, put 3 first on the top and 1 first on the bottom. If I put this y value first from this point, I have to put this x value from this point first. If I put the y value from this point first, I had to put the x value from this point first. And the reason why why we might end up having preferences for how we do this is, as we see here, if we do the bigger y value minus the small y value, we're going to get the y value to be positive every single time. Now, from that, the x value can still be negative in that scenario, so you might end up still dealing with some negatives, but you guarantee that you'll be working with at least one positive, which might not always be the case, as we saw with our other way of doing it. So without further ado, I would love for you to practice a few of these on your own and check the video, pause the video to do that, and then check the video when you're done practicing one or multiple to check answers. So on number 2 here, I would pick one of the y values to start with, and I like to pick, once again, the bigger y value. So 4 is bigger than negative 2. So I'm going to do 4 minus negative 2. Now, as I plug these in, I do put those in parentheses very purposefully. Now, because I put 4 first on the top, I have to put the same ordered pair's x value on the bottom first. So it'd be negative 2 minus 10. Now, on the top, we have 2 negatives in a row. That's important. We have a negative from the formula and a negative from the y value. And so I really add those, and 4 plus 2 is 6. On the bottom, negative 2 and negative 10 become a bigger negative, negative 12, because they're both essentially negative there. And now 6 divided by negative 12 is negative 1 over 2, which, once again, where the negative is, the top, the bottom, the out in front, doesn't even matter a little bit. Number 3 here. So I'm always wanting to pick, once again, the bigger of my two y's to go first. And so I'm going to pick 5 to go first here personally, minus a negative 5, making sure we do, in fact, keep this negative and this negative here. They're both important. And then on the bottom, because I put 5 first, I have to put on the top, because I put 5 first on the top, on the bottom, I have to put negative 4 first, because it comes from the same order pair, minus a negative 8. So on the top, 2 negatives in a row make a positive, and we get 10. On the bottom, 2 negatives in a row make a positive, and we get positive 4, because it's still a negative. And 10 divided by 4 is 5 over 2. Moving on to number 4, the bigger of my two y values is 4, so I'm going to put that one first. And it's not wrong to do it the other way around, it's just my preference. That's what you're going to see me doing. On the bottom, because I put 4 first on the top, I put negative 2 first, and I get negative 2 minus 10, which is 4 over negative 12, which reduces by 4 to become a 1/3, where, once again, where the negative is doesn't matter. I put it out in front this time. Number 5, once again picking my bigger y value, but wait a second, they're the same. So pick one of them. So 9 minus 9. And you might be wondering, okay, well, wait, how do we know which 9 we picked first so we know which x to pick first? And spoiler alert, it actually won't matter. But let me just say, for the sake of argument, I picked this one first. So then I'd pick this x value first and do 5 minus 3. And this would result in 0 over 2, which is just 0. And the reason it wouldn't matter which one you have put first there is, let's say I do switch it around and I say, okay, Now this time, I forgot to put parentheses around these, I put this one first, and so meaning I put this x value first on the bottom. And so I have 3 minus 5. Well, guess what? I get 0 divided by negative 2, which is still 0. Moving on to number 6 here. I'm going to pick to do 8 minus 5 on the top and negative 7 minus negative 7 on the bottom, which, that's interesting. We'll see how that works out. It becomes 3 on the top. On the bottom, we have those two positives. We get 0. And regardless of whether you have the positive 3 or negative 3 on top, depending on your order, it ends up being undefined. Because we can't divide by 0, it breaks math. Number 7. I'm going to prefer to do 9 minus 3 on the top, which means on the bottom, I'm going to be doing negative 1 minus 2. So this becomes 6 over negative 3, which is negative 2. On to number 8. I'm going to prefer to do 13 minus negative 2 personally. On the bottom, that'll leave me with negative 4 minus 6. On the top, those two negatives become a positive that are in a row, and I get 15 over negative 10, which does reduce by 5 to become a negative somewhere on this number, I don't care where, negative 3 over 2. Number 9. I'm going to do 6 minus 5 personally on the top, this minus this. And because I did the 6 first on the top, I have to do the 5 first on the bottom, minus 6. So this leads to 1 over negative 1, which could otherwise be called negative 1. If you called it the green, that's fine. You can always put something over 1. Number 10. So I would do, I forgot to write m equals negative 4 minus negative 4 on the top. You might be wondering, which negative 4 comes first? Well, once again, it will not matter. So let's say I did this negative 4 first, just for the sake of argument. 9 minus 1. So on the top here, I turn those two negatives into a positive, and I get 0 over 8, or negative 8 if you did the other way around. Regardless, this answer is 0. Now, you can't just leave this as 0 over 8. You do need to finish simplifying that one. The only time you can leave it is if it's divided by 1. Moving on to our next page and our last page. How exciting here. Two more of these problems before I change to a slightly different type of problem. So number 11 here, I'm going to choose to do negative 2 first, because that's actually slightly bigger than negative 9, even though they're both negatives. So negative 2 minus negative 9. On the bottom, I'll have 5 minus 3 to match. Sorry, try that again. 3 minus 5. And so on the top, I have these two negatives in a row, and that gives me positive 7 now. And on the bottom, I get negative 2. This does not reduce. Number 12 for the last problem from the set. I'll do 8 minus 6 personally, which leaves me with 4 minus 4 on the bottom. Regardless, you'd get 4 minus 4 on the bottom, which ends up giving you 2 or negative 2 over 0, depending on how you organized it, which is undefined, which you must actually write. Now, let's say we're going backwards. This is interesting. So sometimes you must complete the ordered pairs using a given slope. So for example, if the slope of a line passes the points negative 5, 6 and 5, y, aka you don't know the y value, but you know the slope is negative 4 over 5, find y. So what we do is we take our formula, remembering that our formula is m equals y2 minus y1 over x2 minus x1. And we'll plug in everything we know. Now, here's a little hint for you, okay? As you're working through this, I would encourage you to make whatever ordered pair has an unknown variable, in this case, the second ordered pair, your x2, y2. Now, it doesn't technically matter because you'll be able to get it right no matter what. However, it does make your life easiest with negatives most of the time if you do it this way of making whatever ordered pair has the y value or the x value unknown. And you make that your second ordered pair, so it's listed first in your fraction. So for example, here now as I plug things in, I replace m with negative 4 over 5 because we're told that's the slope. I replace y2 with y because that's my unknown. And on the top, I do that minus 6. On the bottom, I end up having 5 minus negative 5. Now my first step is to just leave the left-hand side the same, and on the right-hand side, where I can simplify, which is the bottom, to go ahead and simplify. So I make those positive, and I create 10. Now we have a fraction equal to a fraction. We learned that when we have a fraction equal to a fraction back in Unit 2, that we cross multiply. So I would do negative 4 times 10, for example, diagonally, and I get negative 40. And on the other diagonal, I do 5 times this entire numerator, y minus 6. So I do 5 times y and 5 times negative 6, giving me 5y minus 30. Now, if your negative 40 is on the left or the right, that's fine, as long as your 5y minus 30 is on the opposite side from it. So now at this point of the problem, we just turn this into a normal equation that we solve. So I'm going to add 30 to both sides to undo the subtraction of 30 and to move it away from my y and toward the other number. I get negative 10 equals 5y. Now if I divide by 5, I get y to equal negative 2. So I successfully found my missing y value. So let's practice some examples of these. Whoop whoop, we gotta do these 8 examples and then we are done with today's notes. So find the missing value using the given slope. So once again, we plug this into our formula, m equals y2 minus y1 over x2 minus x1. So it's going to be 2, or as I like to make it, 2 over 1. I like to make it 2 over 1. That way we have a fraction equal to a fraction here, since we'll have a fraction on the other side. And once again, personally, since this one has an unknown value, I'm going to make that one go first. So I'm going to do 6 minus negative 2 on the top. And it happens to be the bigger y value on the top going first this time. But it won't always be when you do this method. Do the organization, excuse me, that I prefer to do. And on the bottom, maybe x minus a negative 3. So we go ahead and do all the math we can, and that's 2 over 1 staying the same. These two negatives on top becoming positive and giving us 8, and the two negatives on the bottom becoming positive, so we just call it x plus 3. Now we look to cross multiply, and 1 times 8, for example, and 2 times x plus 3, for example. So I'll just start with the 2 times x plus 3 first, just because. And 2 times x plus 3 is 2x plus 6, because you multiply it to each. And 1 times 8 is 8. And once again, which one's on which side doesn't matter, as long as what's on the sides stays the same, as far as 2x plus 1 being on one side and 8 being on the opposite side. Now I subtract 6 from both sides, and we end up getting 2x equals 2. If I divide both sides by 2, I end up getting x equal 1. Number 14. Oh, by the way, if you're ever wanting to check your work for these, you could plug this back in, and you should get 2 once you simplify the slope, which you would. Number 14, so the slope is equal to y2 minus y1 over x2 minus x1, so 3 over 2 is equal to, I'm going to put this order pair first because it has an unknown value, negative 7 minus negative 4 over x minus 0. So we do the math we can, which is 3 over 2 equals, turn these into positive, I get negative 3 over just x. Now as I look to cross multiply, 3 times x is 3x, and 2 times negative 3 is negative 6. I'm going to move this up here as I divide by 3. And that gives me x equals negative 2 for my answer. Moving on to number 15, Burger King foot lettuce. We are going to have negative 9 over 2 equals, I'm once again making this my first one since it has an unknown, y minus negative 4. On the bottom, negative 5 minus negative 3. Do all the math I can over here. Once again, where the negative is here really doesn't matter. Y plus 4, because these are adding, and these are adding as well, and giving us negative 2. I go ahead and cross multiply. 9 times negative 9 times negative 2 is 18, or excuse me, positive 18. Kind of convenient. I took the negative with this one. In this case, as I multiplied, because that created a positive. If you took your negative down here, you just distribute a negative 2 to these, which is totally fine if you do. It's just, whatever you want. So on the other side, if I do 2 times y, I get 2y, and 2 times 4 is 8. So now I subtract 8 from both sides, and I end up getting 10 equals 2y. I'm going to move this up here as I divide by 2. and get y equals 5 or 5 equals y. Which side of the equation is on matters not in the least. Or not in the slightest, excuse me. Yeah, not in the least would work. Anyway, 16, negative 1/2 equals x minus 3 over 2 minus 6. Do the math we can to start, which is just saying 2 minus 6 is negative 4. Now I cross multiply. Negative 1 times negative 4 is 4. 2 times that parenthesis, or the quantity on the numerator, would be 2x minus 6. Adding 6 to both sides gets me 10 equals 2x. Once again, I'm going to move this on up, but after I divide by 2, where I get x to equal 5, or 5 to equal x. Oh, I did something wrong here. What did I do wrong? Let me look. I know I did something wrong here. Oh, silly me, silly me, silly me. I put the x on the top at the very beginning. What an error that is. I should have put the 2 on top and the x on the bottom, because x's go on the bottom. So unfortunately, I have to restart this problem from the get-go. So this would actually be negative 1/2 equals 2 minus 3 over x minus 6. I apologize for anyone I confused with that, which is probably a lot of people. Negative 1/2 equals negative 1 over x minus 6. Now, as we look to cross multiply, negative 1 times x minus 6 would be negative x plus 6, and 2 times negative 1 is negative 2. So if I subtract 6 from both sides, I end up getting negative x is equal to negative 8. I'll go ahead and move this as I divide by negative 1 to undo the negative, giving me x equals 8. That's better. Number 17 here. I'm going to do negative 4 and put that over 1 and set it equal to y minus a negative 7 on the top over negative 3 minus 1 on the bottom. So as I do any math I can here, I get y plus 7, 2 negatives in a row, and over negative 4. As I look to cross multiply, I get positive 16 on one side, and I get y plus 7 on the other. I subtract 7, and I get my answer actually this time of 9 equals y. Number 18, this will be negative 1/5, is equal to 7 minus 8. I didn't put the x on top this time, good for me, over x minus 11. So that's negative 1/5 equals negative 1 over x minus 11. And here, because I'm noticing that I'm going to multiply my negative with my x, and I just rather not have to worry about that later, I'm just going to move my negative down to the bottom part because it doesn't matter where the negative is on a fraction. And if I can manipulate to that my advantage, I'm going to manipulate that to my advantage. So 1 times x minus 11 is just x minus 11, and I create a positive x, good for me. And negative 5 times negative 1 is positive 5, which also made that positive. Once again, good for me. So now as I add 11, I actually just get my answer. I don't have to worry about any negatives with my x. And I get x equals 16. And it always is better when we don't have to worry about negative situations with our x's. You know, real life and in math. Number 19 here, this would be 3/4 equals y minus 5 over 4 minus 0. So simplifying as much as we can to be 3/4 equals y minus 5 over 4. As we multiply, cross multiply, we get 12 equals, distributing here, 4y minus 20. Adding 20, I get 32 equals 4y. And dividing by 4 yields or results in 8 equaling y, or y equaling 8. Once again, where the y is and where the 8 is as far as which side doesn't even matter. Number 20, our last one for the day. 1/3 equals y minus negative 2 over negative 3 minus 9. So we get 1/3 equals y plus 2, as we have two negatives in a row, over negative 12. Seeking to cross multiply here, I do 1 times negative 12 is negative 12. And 3 times this whole thing is 3y plus 6. As I go ahead and subtract 6 here, I get negative 18 is equal to 3y. Dividing by 3 results in y being negative 6. And without further ado, that closes out Algebra 1, Section 5.1.